Hello everyone, this is Curt and I've got another demonstration video for you covering Zitification of web applications. In this video I'm going to do a readout of some recent capabilities that were achieved in the libcrypto.js browser component. This is the OpenSSL WebAssembly component, as well as the Ziti browser core and Ziti browser runtime. We're going to show how nimble the new Ziti browser stack is concerning creation of the certificates that are necessary to get a web app onto the Ziti network. And we're going to be starting completely from scratch. So let's get right into the demo. I'm going to bring up a new private window. So we're starting completely from scratch. Bring up the dev tools. And I want to turn on timestamps and log preservation for this particular demo because I'm going to be referring to how much time it takes to accomplish some things. I'm going to go ahead and hit the Ziti HTTP agent that is in front of our dark Mattermost instance. Go over to the console, scroll up. So what just happened? When the Ziti browser runtime is injected into the page and it comes alive, the first thing it starts to do is take care of everything that is necessary to get onto the Ziti network. Some of it is housekeeping, so we're creating some loggers and browser edge clients so we can get to the controller. But we also spin up the WebAssembly, at which point we can start leveraging it. So once the context is alive and breathing and has everything that we need to get to work, the runtime logic realizes that it does not have any certificates. So it starts the enrollment process. The enrollment process entails doing a logon to the controller using its authenticate method. In this demo, we're still using some hard-coded UPDB credentials to get logged in. We're going to be replacing this very soon with the JWT style authentication. So watch for that in an upcoming demo. Once we have our API session, the next thing we want to do is get a certificate. And the way we do that is we generate a certificate signing request and we pass that over to the controller. In order to actually create a CSR, we need our key pair. And this is how much time it takes to do that. So we come in and get out in about 12 milliseconds in this particular demo. And that's fairly representative of how much time it takes. I've seen it as low as 5. 5 to 10 is generally what we're talking about, at least on my laptop. With the key pair in hand, we can now go ahead and generate our CSR, which we have done here, and we pass that over to the controller here, and it gets the certificate back, and we are now off and running. I don't have all of the rest of the necessary componentry in place yet to actually leverage this cert that we've just got, the so-called ephemeral cert. This is what is going to be facilitating all the mutual TLS to get us from the browser to the edge routers. But let's go back and do the math. So 54,015, and we came up at 53,685 for a grand total of 0.33 seconds. So we came out of the box with nothing. We were not persisting anything in local storage or in cache. We came completely from nothing, and we got all the way to an ephemeral cert in 0.3 seconds. So that is a remarkable speed improvement over the original browser stack. And from a security perspective, this is awesome because we will no longer have a need to persist these. The new WebAssembly we've got in place that is kind of one of the foundational pieces of all the Ziti browser runtime, we get things done very, very quickly. That's all I wanted to show you in this video. The next demo will probably be an increment where we show you leveraging this ephemeral cert to do the mutual TLS connection to the edge router. So keep your eyes open for that video. Should be out real soon now.